this video we will be looking at section 4.3, writing equations in point-slope form. Now point-slope form is just an easier way to write an equation when we have a point and a slope. Whereas in that last lesson we were trying to find the y-intercept, with this model we don't even need to find the y-intercept. If we have a point and we have a slope, we can plug them right in. So our central question will be, how do I write an equation in point-slope form? How do I write an equation in point-slope form? Okay, so let's get our general form, similar to the y equals mx plus b, just a little bit different. But we'll have y minus y1 is equal to m times x minus x1. So this is our slope, m being our slope, and x1, y1 being a given point. So m is the slope. Let's see if we can get some color in here. Put our slope in red. M is the slope, and our point, x1, y1, is a given point. So if we're given a slope and a point, we just plug it right in. So let's do that. Number 1, I got my slope is 3. And then we're given that our x1, y1, x1 and y1 is 2 for x1 and negative 7 for y1. So let's go ahead and plug in. What we'll have, so we're going to use this equation right here. Y minus y1 is negative 7, so we'll have to, it's minus negative 7, so be very careful with that, is equal to 3 times x minus 2. Like that. So there's our slope, there's our y1, there's our x1, plugged right in. Now we would like to clean this up just a little bit. So what we can do, and the only little bit I like to clean up is so I don't have minus and minus. So minus a negative number, that ends up becoming a plus sign. So we just end up with y plus 7 equals 3 times x minus 2. And that's it. So I want to share this, and this is extremely important. When you're asked to write an equation of a line, choose the most efficient model. If the instructions are specific, do what the instructions say. If it says write it in slope-intercept form, write in slope-intercept form. If you're asked to write an equation of a line, this is another form. This is an acceptable form. So be efficient. Okay, so now that you've seen a model, letter A, just plugging in and simplifying, please go ahead and try letter B on your own. So pause right here, see if you can plug this in. and then we'll look at it together. So hopefully you took the time to try this on your own. Let's go ahead and plug in. So I'll identify my slope of -4. So there's my slope right here. This is our equals to m. And then we have our x1, y1 from the point. Now we'll just plug and play. So I'll get y is equal, y minus, using our equation from up here, y minus y1 is equal to m parentheses, x minus x1 close parentheses. So y minus y1 is 2 is equal to m -4 times, using our parentheses, x minus x1, which is 4, and we close our parentheses. Is there anything to clean up here? Nope, no minus and minus around or anything like that, so we can leave it in this form. I know it might feel a little bit uncomfortable, but at least it's less work. So let's be efficient, only do as much as we need to do. That way we don't have to spend time or make careless mistakes along the way. So I'd also like you to go ahead and try letter C on your own. But remember, we need a slope. So when we're finding slope, we'll have to use our equation. M is equal to y2 minus y1 over x2 minus x1. So you'll need to use this to find your slope. Once you find m, then you can use either point. Either point will be okay, but since we like to use a labeling system, I tend to label my first point that I see as my x1, y1, and I can do this x2, y2. So we'll use this x1 and this y1 when we're plugging into our point slope form of the line. So go ahead, pause right here, find the slope, then use this m value that you find to plug into our equation using our x1 and y1 value. So this one was a little bit more involved, but hopefully you tried it out. First thing we'll do is we'll find the slope. So let's go ahead and plug in. Well, I have m is equal to y2 minus y1, 14 minus -2. So I have 14 minus a -2 over x2 minus x1, so -3 minus 5. We get m is equal to 14 minus a minus is plus, so 16. 14 plus 2 is 16. -3 minus 5 is -8. Simplify one more time, that would be -2. Or -2 over 1, both are acceptable. Now we found our m. We're going to plug this in using our y1 and x1. So we'll use that equation, y minus y1 equals m times x minus x1. Now let's plug in. And I have y minus y1 is a -2 is equal to m, which we just found to be -2, times x minus x1, which is 5. And then let's clean it up a little bit, because I see a minus, so let's go y plus 2 equals -2 times x minus 5. Okay, and that's how, if we're given 2 points, we first can find a slope, then we just plug into our general form of this equation, a little bit of simplifying to clean it up, and then we're ready. So D, now this is kind of tricky because we need to first make sure we're in that perfect version of the form before we can identify the pieces. So when I'm seeing an equation like this, there is a point and there is a slope, but I'm not quite in that perfect version. Because remember, my perfect version is y minus y1 is equal to m times x minus x1. So when I look at this, I have y minus. There's my y minus. So it's already set up on this side. I have y minus, so I know my y1 is going to be 2. So this is my y1. And when I keep going down the line, I see that I have an m. I have a number outside my parentheses, so we can call that our m. But what's unfortunate is that this x plus 1 is not exactly what we see up here. We need it to be x minus. What we have right here is x plus. So I'm going to have to rewrite the equation so that I have a minus. Well, how do I turn a plus into a minus? It's kind of like some reverse thinking. Well, if in all our previous examples, if a minus turned into a plus, I can go backwards and take a plus and turn it into minus a negative, or minus a minus. So let's do that. So I'm going to rewrite everything. So I'm going to have y minus 2 is equal to negative 2 times x. Now we're going to turn that plus, like we did in the previous one, turn that plus into minus a minus. So x minus a negative 1. Now we have all our pieces. The number that follows the minus sign is our point, y1. Then I have x minus. Now this negative 1 is my x1. And then that number out front of our parentheses right here, that negative 2 is our m. So now we've identified all our pieces. So let's clean it up a little bit as far as the labeling. So we can see it. I have x is equal to negative 2. We'll need that over 1 to help us graph. And then we have the points negative 1, comma 2. Now this is very similar when we're graphing these. It's very similar to y equals mx plus b. I start at a given point, and then I'll apply the slope. So we'll start here. And then we'll use the slope. So we'll put our pin on this point, and then we'll count using the slope to find our second point, and then we'll connect the dots. So we'll go to negative 1, comma 2, negative 1, up 2. So this is my starting point. I'm going to start at that point. Now I'm going to use my slope. Down 2, rise over run. So down 2, negative 2, run of 1, positive 1, so to the right 1. So I'll go down 2, and then to the right 1. Let's do it again. Down 2, to the right 1. Now we can connect our dots. And there's the slope of our line. So the key main point for this is first converting the equation so that we have that y minus and we have that x minus. Then we can really see what our x1 and y1 are. And then that other idea is, where do I start? How do I graph? Well, we start at a point, then we use the slope. Okay? So that is how we can write equations in point-slope form and use equations written in point-slope form to graph. Thank you for watching the video, and I hope you have a great rest of your evening.